Learn efficient pharmacology. Passage of drugs across the plasma membrane. Part 8. Concentration gradient. A common theme in many of our previous discussions was concentration gradient. To understand this concept better, let's use an example. Consider two identical tanks, one full of water and the second relatively empty. If we connect the tanks by a tube, water will flow. Did we have to provide any energy? No. The water in tank 1 already has a greater potential energy due to its higher level. So, this water does not require any additional energy to flow into tank 2. The principle in concentration gradient is very similar. Like the water in the first tank, the ions on the left also have a greater potential energy due to their higher concentration. Just like the tube facilitating the flow of water, a channel can facilitate the flow of ions without using any additional energy. This is what happens in facilitated diffusion. Now from here, can the water flow backwards? Obviously not, because the potential energy of the water in the first tank is still higher. However, water can be pumped back if we use energy, for example in the form of electricity. Likewise, the ions cannot flow against the concentration gradient on their own either. But they too can be pumped back using energy, for example in the form of ATP. Thus, movement against the concentration gradient always requires additional energy, or in other words, is an active process. Now the water levels are back to where we started. If we simply allow the water to flow, we would be wasting a lot of potential energy. Instead, it can be used to do some work. For example, to turn a water wheel. Our body also does the same. The potential energy of ions is often put to good use by transporters. Such transporters can then move other solutes against their concentration gradients. This is what happens in co-transport. The flow of water can also be used to turn a turbine to generate electricity, the energy currency of the modern world. Then there is one obvious question. Can the flow of ions also be used to synthesize ATP, the energy currency of the cell? Absolutely. In fact, this is how ATP is synthesized in the mitochondria. By using the flow of hydrogen ions across the inner mitochondrial membrane to turn the turbine ATP synthase. This is a good to know fact. This is a summary of our discussion on concentration gradient.